Hi guys, so we are continuing with our videos on differentiation under Math SL. We are continuing with the review series, and this is the first advanced level video in this series. I shall be solving the 3 questions on the screen in front of you, and I shall begin question 1 shortly. So the first question came in paper 1, May 2013, time zone 2, question 10. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. This is the first part of the question. We shall solve it, and then I shall give you a chance to look at the rest of the question and attempt to solve. So we are given a table of values for x equals 2 and x equals 3. We are given the values of f, g, f dash, g dash, and h double dash of x. Now, we are required to find g of 3. This is obviously the value of g of x when x equals 3. So this is negative 18. Next, we are required to find f dash of 3. So f dash of 3 is f dash of x when x equals 3. So this is 1. Finally, we are required to find h double dash of 2, which is the value of h double dash of x when x equals 2, and the value is negative 6. So these are the 3 numbers that we are required to find in question A. So this is the rest of the question. Kindly take a minute to look at the question and attempt to solve before I continue with the answer. Bear in mind that you shall need to refer to the table that was there at the beginning of the video in order to solve some of these questions. So I shall give you a minute to look at the table as well. There is your table. You might want to copy it down for reference while you are attempting to solve the question. And there is the question we are trying to solve. So in B, we are required to explain why P is a point of inflection, given that we have 2 graphs, the graph of H and the graph of H double dash. So by definition, a point of inflection is a point where f double dash is 0, or in this case h double dash is 0, and h double dash changes sign from negative to positive or from positive to negative. So point P is a point where x equals 3. From the graph of h double dash, even though P does not exist on h double dash, it's not drawn here on h double dash, but we know that this is the point where x equals 3, and from the graph of h double dash, the point where x equals 3 is a point where h double dash is 0 and where h double dash changes sign, because before x equals 3, h double dash lies below the x-axis, so h double dash is negative. After x equals 3, h double dash lies above the x-axis, and hence h double dash is positive. So at x equals 3, h double dash is 0 and changes sign. This is the definition of a point of inflection. Hence P is the point of inflection on the curve of H, as deduced by analyzing the curve of H double dash. Had the curve or the line of H double dash not been provided, we could have simply observed that P is the point where the graph of H changes concavity. Before P, H is downwards concave. You can see that it's frowning. After P, H is upwards concave or smiling. So P is the point where the curve changes concavity. So hence P is also the point of inflection. But you wanted to or needed to refer to the fact that H double dash changes sign as given in the linear graph. So moving on to question C, we are required to find the y-coordinate of P, and the y-coordinate of P is given by h of 3, because P lies on the graph of h. Hence, P equals h of 3, the value of h of x when x equals 3. H of 3 is found using this equation. But instead of x, I'm going to put here a 3 and here a 3. So I need to find f of 3 times g of 3. And I shall refer to the table in order to do that. So since f of 3 is 3 and g of 3 is negative 18, hence h of 3 shall be equal to 3 times negative 18. So h of 3 is equal to f of 3 times g of 3, which we got from the table as 3 and negative 18. Hence the answer is negative 54. Finally, in question D, we are required to find the equation of the normal to the graph of h at P. And in order to find the equation of the normal, we need a point and a slope. The point is provided, which is point P, and we know that the x-coordinate is 3, and the y-coordinate has been obtained in question C. So we already have the coordinates of point P. What remains for us to do is to find the slope of the normal line. So first we need to find the slope of the tangent line at P, and the slope of the tangent line at P is given by h dash of 3, h dash when x equals 3. So how do I find h dash when I don't have an equation? Using the product rule and using this formula right there. Since h equals f times g, we can deduce that h dash shall equal fg dash plus gf dash, which is the same as saying uv dash plus vu dash. The u here is f of x, and the v is g of x. Hence, h dash shall equal fg dash plus gf dash. And since we want the slope at P, so we are talking about all of these functions when x equal 3. So we want to find f of 3, g dash of 3, plus g of 3, f dash of 3. And these are found using the table. So uv dash is fg dash, so fg dash is 3 times negative 3. f of 3 times g dash of 3, which is 3 times negative 3. Plus g f dash. So g f dash is negative 18 times 1. And I need to evaluate this number. So this is the equation. H dash of 3 equals f of 3 g dash of 3 plus f dash of 3 g of 3, and these numbers have been obtained from the table as I've shown you. Hence the slope is negative 27. If the slope of the tangent is negative 27, then the slope of the normal is positive 1 over 27. Having obtained the slope and having obtained the coordinates of the point, I can use the point-slope formula to write the equation of the normal line. Y plus 54 equals 1 over 27 times x minus 3. So this concludes our question. Take a minute to write the answers down if you will, and I shall begin the second question shortly. So the second question that we shall solve came in paper 1, May 2015, time zone 1, question 9. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So you are given in the question that f dash of x equals 3x squared minus 2kx minus 9, and you are required to find f double dash. So if f dash is 3x squared minus 2kx minus 9, this differentiates to 6x minus 2k. Next, you are told that the graph of f has a point of inflection when x equals 1, and you are required to show that k equals 3. So we begin by defining the point of inflection. This is the key word in the question. A point of inflection is a point where f double dash is 0 and changes sign from positive to negative or vice versa. So we want to use one of these two properties, that it equals 0 when x equals 1, or that it changes sign. So obviously, since this is an equation, we are probably going to use the first property, which is that f double dash equals 0. So I'm going to plug x as 1 into f double dash and set to 0. So this is what I've done right there. When x equals 1, f double dash equals 0. Hence, I've just plugged 1 into this x and I've obtained 6 minus 2k equals 0. Hence, k equals 3. In question C, I'm required to find f dash of negative 2. Now that I have the value of k, I'm just going to plug negative 2 into this equation using the value of k equals 3. This is what I've done right there. I've just plugged negative 2 into the x and 3 into the k, obtaining an answer of 15. Next, I'm required to find the equation of the tangent to the curve of f at negative 2, 1, giving the answer in this form. Again, I begin by the key requirement of the question. I want the equation of a tangent. So I need the point and the slope on the tangent line. I'm given a point, negative 2, 1. So what remains for me is to find the slope when x equals negative 2. So I'm just going to plug negative 2 into f dash of x to get the slope of the tangent line. Luckily, I've already done this in the previous question. And I know that f dash of negative 2 is 15. Hence, I just want the equation of the line that has point negative 2, 1 and slope 15, which is the answer to question C. So there is my point, negative 2, 1. There is my slope, 15, which is f dash of negative 2, which I've obtained in C. Now, I just use the point slope formula, which I've done right there, and I expand and distribute and simplify until I obtain the final equation in red right there. Finally, in question E, I'm required to explain why the graph of f has a local maximum when x equals negative 1, given that f dash of negative 1 equals 0. Now, again, let's start with the keyword, local maximum. What does local maximum mean? A local maximum is a stationary point, hence f dash has to be 0, and in particular, the local maximum is a point where the curve is frowning or concave downwards. And since the curve is going to be concave downwards, hence we know that f double dash has to be negative. So to summarize, a maximum point has two properties. F dash has to be 0, f double dash has to be negative. I'm already given that f dash equals 0. F dash of negative 1 equals 0. So to explain why there is a local maximum, I have to prove that f double dash is negative. So I have to plug this value of x into f double dash and prove that the answer is negative. So this is what I've done. I've plugged negative 1 into f double dash, obtaining negative 6 minus 6, which is negative 12. Hence, since the answer is negative, and since I already know that f dash of negative 1 is 0, I have satisfied the two conditions for a maximum point. So this concludes our question. Take a minute to copy this down if you will, and I shall begin question 3 shortly. So the third question that we shall solve came in paper 2, May 2000, question 7i. Kindly take a minute, attempt to solve, and the answer should follow through shortly. So question A gave you y equals e to the power of 2x cosine x, and you are required to find the derivative expression and show that it looks like this. So this is an easy implementation of the product rule. There is our u, there is our v, this is u v dash, and this is v u dash. And in order to match the expression in the question, I shall take out e to the power of 2x as a common factor, and the remaining terms are negative sine x and 2 cosine x. So this is what my final expression shall look like. In question B, I'm required to find d squared y by dx squared, which is y double dash, the derivative of the derivative. So since the first question was a show that question, even if I don't manage to solve it, I should use the answer that they gave me in order to solve the following question. I shall differentiate this orange expression, and again this is the product rule. There is my u and this bracket is my v. So this is my u v dash expression and this is my v u dash expression. And in this purple equation, all I've done is distribute this 2 right there. I've distributed it on the second bracket, so I got 4 cosine x minus 2 sine x. Now to go from the purple expression to the red expression, all I've done is take the e to the power of 2x out as a common factor, and what remains is the bracket right there, negative 2 sine x minus cosine x, added to the bracket right there, which is 4 cosine x minus 2 sine x. Next, I simplify, arriving at the final expression in blue right there. In question C, we are told that there is an inflection point at P, A, comma B, this point right there. Use the results from parts A and B to prove that tan A equals 3 over 4. So we need to use the results of the last two questions to show that tan A equals 3 over 4. Of course, this is not a usual question, this is unusual. However, let's see how to work that out. So we begin by the key word in the question, which is that there is an inflection point. So what do we know about inflection points? We know that the second derivative, y double dash, has to be 0 at an inflection point. So I have an expression for the second derivative right there, and I shall set this equation to 0. And since we know that e to the power of 2x can never equal 0, so we don't really need to include it into the equation. So I just get 3 cosine A minus 4 sine A equals 0, where A is the value of x at the point of inflection. Point P has x coordinate A. Hence 3 cosine A minus 4 sine A equals 0. If I solve this equation, I just took the 4 sine A to the right hand side, obtaining this form of the equation. Then I divided by cosine A, getting 3 over 4 equals tan A. Next, I need to prove that the gradient of the curve at P is e to the power of 2a. So the gradient at point P, which I shall call m of tangent at P, is the gradient at the point where x equals a. So I evaluate that by f dash of a. So I'm just going to plug a instead of x into this equation. Hence I get e to the power of 2 cosine a minus sine a. Excuse me, e to the power of 2a times 2 cosine a minus sine a. Now, I want to evaluate this expression, but I don't have the values of sine A or cosine A. I can use the GDC or the 3, 4, 5 right angle triangle to get the values of cosine A and sine A, given that tan A equals 3 over 4. So you know TOA, tan A equals opposite over adjacent. So if this is angle A, the opposite side shall be 3 right there, and the adjacent side shall be 4, which I've done right there. Hence the hypotenuse is 5, so I can use SO and Ka to find values of sine A and cosine A. So cosine A equals 4 over 5, adjacent over hypotenuse, and sine A equals 3 over 5, opposite over hypotenuse. Since this is a paper 2 question, you could have just obtained inverse tan of A, inverse tan of 3 over 4, and then obtained the sine and cosine of the answer. However, it is useful to know the 3, 4, 5 right triangle in case a similar question appears in paper 1 where there is no calculator. So now that I've obtained the values of cosine A and sine A, all that remains is to plug them into the equation. 2 cosine A is 2 times 4 over 5, so I get 8 over 5, minus sine A, which is 3 over 5, so that's what I've written right there, and the e to the power of 2a remains as is. 8 over 5 minus 3 over 5 gives me 5 over 5, which is 1. Hence my final answer is e to the power of 2a. So take a minute to copy this down if you will. This concludes our question and this video. I hope you have found it useful.